All right, chapter 2 deals with the main concept of a derivative. So in the very beginning here, we're just going to talk about what a derivative is and then estimate derivatives using graphs. And these are just, estimates, so they're not quite exact. So if I have a couple of pictures here and I say estimate the slope of your curve of the function at any particular point, I'm just going to call it x comma y. Well, if I just have one point here and I draw a straight line through this point, by the way, what we're doing is we're drawing a line tangent to the curve. Tangent to the curve means it hits the curve in one spot going through a certain point. Well, then I can, if I want to estimate that line, the slope of the line, I would just do my rise of a run. So then I would pick any 2 points on this red line. Well, the reason why this is just the beginning of the chapter is, where exactly do they want me to draw the line? I mean, if they want me to draw the line here, I can easily go, okay, from here to here, I'm going to go up 2 and over 2. So it kind of looks like my slope might be 1. But let's say the line was here. Well, then the slope might be different. I might go, up this far and over this far. Well, I don't really know where they want me to draw the line, so what about this one? So we're just kind of showing you that the whole concept of derivative stems from finding tangent lines. And once I find tangent lines, I need to determine the slope doing rise of a run. And then what's going to happen, and I'll talk about this a little bit later on, but I just want to talk about it quickly here, is instead of giving you 1 point, they're going to give you 2 points. And then we're going to eventually get these 2 points closer and closer and closer to each other. So for right now, let's go back to that first line. And what's the slope of the line? Well, all I need to do is do my rise over run. And then I would say that my slope would be up 1 over 1. So my slope is 1 over 1. Okay, not a big deal. Obviously, if I say find the slope of the curve here, what I'm really saying is find the slope of the tangent line. So I could draw a tangent line here, and then my slope might be something different. It might be up 1 over 2. So when they say estimate the slope of the curve, what they really mean is find the slope of your tangent line. And again, remember that tangent line is intersecting the curve at a point. Let's look at the second one. So if I want you to figure out the slope of the curve at this particular point, I might draw a tangent line like this. Don't have a ruler here. But I might say, okay, I'm going to go down 1 and over 2. Okay, but what if I said, okay, estimate the slope of the curve here? So in this one, I might go down 1 over 1.5, which is really this, which would result in this. So I want you to see that we're just estimating slopes. Well, what if they don't give you a picture? What if they give you a table of some values? Yeah, you could plot these, but there's no reason. Because how do you find slope? Remember, it's slope of the tangent line that's hitting or intersecting your function at one spot, which we call xy. Well, in this case, they're asking us to do it right here at 2. So I want the slope of my tangent line hitting the function at this point 2, 5. Well, normally I would just draw my picture and I would draw the tangent line and then I would do rise of a run. But since I don't have that and there's no point in me going through and trying to graph all this, what I'm going to do is I'm going to use this point for sure and then pick another point somewhere close, either 1.8 or 2.2. Doesn't matter. I'm just going to pick 1.8. And I'm going to do my normal slope equation. And even though the formula says take your second one, subtract your first one, it doesn't matter as long as the order is consistent. So I'm going to do this one, take away this one, just so I have positive numbers. So 5, take away 4.24. and 2 take away 1.8. And then I'm just going to divide those. So then my slope is approximately 3.8. And that's fine. That's all I need. Now I didn't have to use 1.8. I could have used 2.0 and 2.2.